In this problem, it says that researchers collected data on the numbers of hospital admissions resulting from motor vehicle crashes, and results are given below for Fridays on the 6th of a month and Fridays on the 13th of the same month. So we're going to use a 0.05 significance level to test the claim that when the 13th day of the month falls on a Friday, the numbers of hospital admissions from motor vehicle crashes are not affected. So we have our sample data given here. And we want to know, first of all, what are the hypotheses for this test? So mu sub d is the mean of the differences in the numbers of hospital admissions. And we are going to test the hypotheses that mu sub d is equal to 0, and then, which is reflecting that the number of crashes are not affected, and then mu sub d is not equal to 0. They didn't give any indication that it should be higher on Friday the 13th or lower, so this is a two-tail test and we're using not equals. So we're going to start by finding the value of the test statistic, and you can do this by putting the Friday the 6th data into L1 and Friday the 13th into L2, and then we can make list 3 L1 minus L2 or L2 minus L1. They didn't give us any indication in this problem which way they wanted us to subtract, and it's a two-tail test, so you can really do it either way. And your test statistic will come out to the same value. It'll just be either positive or negative depending on the order in which you subtract those two lists. So we have L3 is the difference between L1 and L2 in whatever order, and then we're going to run a t-test. And we're going to do this using data. And our list is L3. And our hypothesis, let's see, well, mu 0 is going to be 0. And then our hypothesis is that mu is not equal to mu 0 because it's a two-tailed test. Okay. So when we do that and we get our results, we get a test statistic negative 3.005. So I've put a little t-distribution here. It's really a normal distribution, but it looks roughly the same as a t-distribution. So for our purposes, that's going to work fine. And where is our test statistic? Our test statistic is here just beyond negative 3. Okay. And next we want to identify the critical values. So in order to do this, because this is a t-distribution, we're going to use inverse t, and it's a two-tail test. So we want to know what are the cutoff values that give us a total area of 0.05 in the tails. So if the tails have to total to 0.05, then this area is 0.025. Just cut 0.05 in half. And this is also 0.025 in this area. And remember that area goes on forever. Okay. So So for inverse t, I'm going to put in 0.025. I'm just going to find that left-hand critical value first. And I have to give the degrees of freedom. There are 6 pairs of value, so my degrees of freedom is 6 minus 1. And when I do this, I get negative 2.571. And if I were to actually calculate the other side, this is going to be 1 minus 0.025. And degrees of freedom is still 6 minus 1. And I get positive 2.571. So I didn't really need to do both of them. I just need to find one of them, and my critical values are plus and minus that value. So now I know that those are my critical values. Let me go ahead and mark this off here. So this is 2.571, and this is negative 2.571. So your critical values determine your rejection region. And in this case, we can see that our test statistic is falling in that rejection region. So we are going to reject the null hypothesis. If my test statistic had fallen somewhere in the center here, then we would have failed to reject, but it didn't. So we reject the null hypothesis. So, the null hypothesis said that crashes were not affected. But what we're seeing is there is a definite difference. So, based on the sample information, this is a very small data set. So, you'd want to be careful with that. But for our purposes, we're going to say we have strong evidence that the number of crashes is affected by the date. So we rejected the null hypothesis, and when we write our statement, we have to consider what the claim was. The claim was the null hypothesis. So when your claim is the null hypothesis, then you want to write a statement about whether there was sufficient evidence to reject the claim. If the claim had been the alternative hypothesis, which it usually is, then we would write a statement about whether there was sufficient evidence to support the claim. But because the claim is the null hypothesis, we are going to say we did reject the null hypothesis, so there is sufficient evidence to warrant rejection of the claim of no effect. So that looks like both A and B. So I can eliminate C and eliminate D as answers. And what do we think then about hospital admissions? They do appear to be affected, right? There does seem to be a difference between the Friday the 13th data and the Friday the 6th data. So that's how you do that problem.